Good evening and welcome everybody. It's Obi-Wan Pez for N-Simplex Pachinko. We are going to be doing some mathy stuff tonight. Finally got the energy up. Woo! So, rather than taking a nap, we're going to actually do some math. So, tonight we're off in cracking the GRE Math Subject Test, Princeton Review 2nd edition from 2002. The math doesn't change that much. We're currently working in the Calculus 2 material and doing the unit review that's on there. There are a total of 50? Yes, 50 questions. We're currently working on number 11. And if anybody is here for any other questions and stuff like that, we're going to take those as priority because this just serves as a framework to have problems to work on. But like if you all have actual questions, then I would much rather answer those. So, welcome on in, and good evening to Bistolis, Sucknow, and yep, got the two of you. Great. I am currently using Excalidraw, which is just a standard web app. It's not even like sorry, getting a little oop. Oh dear. There we go. So yeah, I'm just using a Excalidraw and then a Wacom tablet, which has a nice little stylus that goes with it. Nothing super fancy, just, you know. Tablet itself was 200 USD. It seems to be about my price point for literally any upgrades on this computer. Quality's very good as far as I can tell. And I don't need anything super fancy. Without the glove. So with the like artist glove, it's very nice and smooth and slides nice and easy. Without it, I tend to sweat, and I personally stick a lot because I just have grossness. But that's me. Like other people have perfectly dry hands and they glide right over this stuff. The other reason that I usually have a glove on is that I use hashtag not sponsored a balm. This is Hardcore Hand Care from Greenland, New Hampshire. Hometown shout out. I mean, not exactly, but close enough. So I usually use this stuff is beeswax based, and if it were to get on the electronics, like on the surface it wouldn't cause any problems, but it's kind of sticky a little bit. That's also 25 years old. So some of the ingredients are starting to separate just a little bit. You received one yesterday but haven't even unboxed it. Nice. This is a Intuos 6100. Looks like it. And like I said, it works very well. I haven't really made use of the clicky buttons either here or on the tablet itself. For the most part, like, I think the left button I set for undo and the right button I set for redo, but like everything else is just nah. 50 to 60 euros, yeah. So like I had an original. I found out like the Wacom Bamboo, which was from 2010 maybe, which my boss at the community college gave to me in like, I don't know, 2014 or something like that. Was like, see what you can do with this, to see if I could, like, go online and make some YouTube content basically. And if you go back to like the very, very early stuff on my channel, boop, N Simplex Pachinko 6542 on YouTube. If you go all the way back to like my earliest videos, you can actually see like it's very chunky, it's very pixelated, and it's like all over the place. And I'm not particularly proud of those, but at the same time, it does serve as both like, look how far we've come, and also there are some pieces of information that I have shared in those days which I have not updated since. So I'm not sure exactly what. I'm going to have to go back and like redo a lesson plan or something. But it also shows a little bit of my like evolution of teaching as I go through the years. But yeah, you can see the original bamboo tablet, which, like I said, very chunky, very pixelated. It looks pretty awful. But over the years, it's gotten, just having like more experience with it, it got better. And then also, once we reached lockdown in COVID 2021, like we got to probably October, November of 2021 when I was like, okay, I need an actual like good tablet. It can't be that late, can it? I think it must have been beforehand, because I was just like doing an online thing. I remember going to my associate dean and being like, is there any way I could get like, reimbursement for this? And he was like, yeah, no. If you're using it for your own stuff, that's on you. I was like, yeah, I mean, fair. Right, and it's not like it wasn't theirs. I was not borrowing it. It was something that I was going to have to buy. So. Because Alan, Bob is part of Candidate 1 or Candidate 2, but Alan is not an element of Candidate 2 and Bob is not an element of Candidate 1. Alan and Bob are elements of Compound Candidate 1, as well as Candidate 1 and Candidate 2 are a subset of Compound Candidate 1. Okay. Fair. I would probably say that makes sense. I'm not saying it's going to be like correct, but sounds right. That may also be if you're looking at like having to do this as string variables, you may have to do this as concatenation. But that's, you just don't know how you would write it in set theory. I mean, I think that the thing that you wrote above makes sense. I'm not actually an expert on set theory. Do you know Penn Center? I think you've been over there. If anybody has any other, yeah, okay. if anybody has any other needs, I would highly recommend these awesome people. Slim from Academy of Useless Ideas. Dr. Gold from Actual Education does mostly physics, but knows a fair bit of math. Don Factorial is an awesome tutor. Ian Stuckey is, well, I'm not sure exactly where Stuckey fits in to, like, what's their specialty, right? They do high-level theoretical math and are working on papers anyway. Zach from E to the 2I Pi is, like me, an educator, and so, like, working on math education type stuff. He's taken a bit significantly more, like, hard math subjects, and I've basically been subsumed. It's fine. Now, Zach and I have similar perspectives, but at the same time, different backgrounds. So it makes it kind of interesting to see how we come about it, like looking at the same things, but like slightly different viewpoints. Meriwether Remark is typically another like tutor type person, does a bit of, I think, more engineering math, but also really good perspective. Penn Center is a department chair at a junior college up in British Columbia, Canada, and does all sorts of stuff. So teaching linear algebra for the most part, I think, so far. No, that's not true. He just said he is going to be teaching linear algebra this summer, I think, or maybe in the fall. PhoboStream. Phobos has a lot of math background. I can't remember what her specific subset area is. Physics and depression. Physics and depression. Talos teaches. Talos hasn't been around in a while, which is really too bad. They're pretty awesome at like general mathy type stuff. And the Tutor Wizard, also not entirely sure what they do, or what subset of math they do. Typically, I will try to bend stuff in the direction of multivariate linear algebra and differential equations. Differential equations is sort of my specialty. That was the double classes that I took in grad school. We had to take 2 classes that were connected at the higher graduate level. So I did partial differential equations and nonlinear differential equations. And I've spent a long time teaching, both teaching ODEs and then also learning ODEs from multiple perspectives and being like, okay, so how are we going to teach this? And then how else can we teach it? To try to get a whole bunch of different ideas on the board. Yeah, Zach from E to the 2I Pi is way better at the real analysis bits, and Penn Center is really good at complex analysis. So we've each actually taught a class here on Twitch. I taught differential equations, Zach did real analysis, and Penn did complex analysis right here. So, school teacher currently in 2nd semester, special education master. Nice. I had a class. It was like my first real assignment. I had a full year in Baltimore County, which was technically just outside the city, but at the same time it was within the beltway of Baltimore. So one could argue it's like borderline Baltimore City. Um, you're thinking about fooling around on Twitch. It's really pretty awesome place to like get a bunch of people to critique your work. And I gotta say, like, the people around here are generally pretty friendly. So real and complex, you have to be good in proofs and sets. Yeah. So yeah, each of the three of us have taught one entire class on Twitch, which allowed us to get a lot of feedback on, how do we teach math? How do we teach our specific math? And then, like, what are ways that we can try to improve a bit? Zach and I have both really been interested in Building Thinking Classrooms by Peter Liljedahl, and it's transformed the way that both of us teach in the classroom. It's a little bit harder here on Twitch to try to, like, do some of these experimental teaching things, but it was pretty neat to try to implement a little bit and see how that worked. Generally speaking, it's a lot of get the students to engage with each other and become slightly more independent by allowing the teacher to step back and be a router of information rather than the encyclopedia, which everybody is going to start using to get answers. My first real teaching assignment inside of Baltimore was I had I had like 7 classes, I think, and they were all Algebra 2, essentially. And then I had one Algebra 1 class, which was, it was 3, but it was on block schedule. So, like, it was just gigantic. So, like, 3 block scheduled Algebra 2s and 1 Algebra 1 that was co-taught with a special education teacher. So, like, she was trying to learn the math, and I was trying to learn the special education, and then the both of us got really good synergy going on because we're like, okay, let's try and figure out how to make this work for everybody in the classroom. Most of our students had an autism spectrum disorder, and they were like just the most wonderful kids you could ever possibly imagine. I loved working with all of them and seeing like the different perspectives and insights that they all had in trying to understand algebra. Yeah. Okay, if f of x is a function that is differentiable everywhere. I was hoping you'd say that. What is the value of the following limit? All right, limit h approaches 0 of f of x squared plus 3h squared minus f of x minus h squared all over 2h squared. Whoa. Hate it when it does that. Okay, right. Okay, so if it is differentiable everywhere, then we know that the f prime of x is equal to limit as h goes to 0 of f of x plus h minus f of x all over h. This is not even remotely close to what we're seeing. That is rather impressive. Okay, so if we were to just naively plug this in, right, that gets us f of x squared minus f of x over limit as h goes to 0 of, right, 2h squared, which realistically, right, we could just 2h squared there. Yeah, me too. I think the problem is that I'm just not expecting it is the issue, right? So if h were just naively plugged in, we end up with this thing, f of x squared minus f of x over what is essentially going to be 0. Oh, whoops. Oops. That is not x squared. It is f of x plus 3h squared minus f of x minus h squared all over 2h squared. All right, options. All right, A is 4 f prime of x. B, so that's what this is, 2 f prime of x. C is going to be just f prime of x, which I very much doubt. But hey, I'm not going to judge. D is 1/2 f prime at x, and E, the limit does not exist. Okay, That's also not f at x squared, that's just f at x. Right, so this is going to be a 0 over 0. It is okay, so wait, if that's the case, right? Okay, I think maybe. Let's try something. Right, so this is going to be 0 over 0, which is indeterminate. So by that token, we should be able to say, hey, let's take the derivative of both the top and the bottom by h. Think of this in terms of a function of h rather than a function of x. I mean, that seems perfectly likely. If we do that, right, the limit as h, oh yeah, right, because h is the operative variable here. Yeah, we could. We would not get the GRE if we just replace h squared with something. Yeah, you know what? Let's do that. Leaning toward a half. Right, let h squared equal m. Right, so then m is going to go to 0 as we get f of x plus 3m over, no, minus f of x minus m over 2m. Okay, now let's treat this as a L'Hopital's rule with m as our operative variable. And so at this point we say that this is going to be equivalent to limit as m goes to 0 of, this is going to be f prime at x plus 3m times the derivative with respect to m of the inside, which is 3. And Kim. Yeah, we could take on any unrelated questions you might have. Can't guarantee we're going to do it immediately, but you know. This is going to be f prime at x minus m times, again, take the derivative with respect to m of the inside, and we get -1. You know what? I think it's going to be a 2. All over 2. Yeah. So m goes to 2. Oh, just... Right, so this is going to be 3 f prime at x plus 3m plus f prime at x minus m all over 2, which means that this is going to be the limit. Well, we could just take the limit, right? 3 times f prime at x plus f prime at x all over 2, which is 4 over 2 f prime, which is 2. Cool. Yeah, some little tricky nonsense like that. B. Yep. The spouse said the same thing. L'Hopital with respect to H. Although I guess with H you're going to have to do it twice. So, sorry. Okay, so we don't need this, actually. The issue was we could do L'Hopital's, but treat your h as the operative variable and use substitute the h squared for a simpler variable. Makes it much nicer. All right, cool. That's 11. 12. So if you were to try it just with h, right, then the numbers that were coming out here would have been 6h rather than 3. And then over here it would have been a negative 2h. And then down here would have been a 4h, which, okay, I guess the h's all divide out as well. And then it would have been 6 over 4, nope, not 6. 8 over 4 instead of 4 over 2. But it's still a ratio of 2, so either way. Never mind. Would have worked the same. All right, 12. Oops. Yeah, h's all just divide out. What is the equation of the line tangent to the curve xy parentheses x plus y equals x plus y to the fourth at the point 1, 1. All right. Come back to that in a sec. Quick yes or no question on Introduction to Analysis. I'd like to know if the premise of this theorem is ill-informed. Seems like a missing quantifier for x. Let f be a real-valued function whose domain is a subset of the reals. Then f is continuous at x sub 0 in domain of f, if and only if, for each epsilon greater than 0, there exists a delta greater than 0, such that x in the domain of f and the distance between x and x0 is less than delta, implies that the distance between f of x and f of x0 is less than epsilon. Yeah, no. I think we're good. As long as x is within the domain of f, and x0 is also in the domain of f. The only problem I might foresee is if it's an endpoint, then you're implying the one-sided limits, but whatever, it's probably fine. Oh, okay. I think it has to hold for all x's within the domain. Yeah, and x should be very close to x sub 0, but... Oh, yeah. It can't... Okay. It can't hold for literally all x's, right? It's not possible. But, it holds, right, it holds for all x's within delta of x of 0. Yeah. So I guess if you want a for all x's, that's going to go after the and. For all x's for which this is satisfied. The absolute value of x minus x0 is less than delta. Yeah, no, that's fine. I don't blame you. Okay, so 12. Oh, whoops, that's number 13. It's fine. Oops. Delta epsilon stuff is mind-boggling first? Yeah. Using the epsilon delta as a theorem rather than definition of continuous function. Yeah. Yeah, it's just what standpoint are we using? So if somebody comes up with most of the books do treat it as a definition, that they're like, this is true. And then we'll go back and look at the proof of why that is, which it is therefore a theorem because we're saying, okay, using the previous knowledge, we can build off to get this new knowledge. It's just that it's not stated as a theorem. It's being stated as a fact, and then you better get used to it. All right, equation of the tangent line of the curve. So we need to find dy dx at 1, 1. And then that's going to be equals m, where y equals mx plus b, or y minus y0 is equal to m times x minus x0. Alrighty, Anakim. Good luck. Have a good night. I mean, it looks like it's a PDF. Tech. Some teachers' tech notes. Okay. So we could go about this multiple ways. If we're just trying to find dy dx, then I would probably just say this is a product rule. So we try to find the repository. Okay. Elementary analysis. Nice. 2013. Okay, so if we're going to do this as a product rule, we have 3 separate elements, the x, the y, and the x plus y, which all need to be differentiated as a product, as a compound product. So, like, you could do it separately and say xy is one thing and x plus y is another. It doesn't matter. You could multiply it out and do all those as an individual small product. Doesn't matter. But either way. Yoink. So if we take the derivative of the first item, which is x, we just get 1 times y times x plus y. Then we take the derivative of the second part, so x times dy dx times x plus y, plus leave the first, leave the second, take the derivative of the third. So derivative of x is going to be 1 plus dy dx is equal to, take the derivative of x is 1, plus take the derivative of y to the fourth is 4, y to the third dy dx. Okay, so now we need to take all of the dy dx terms and put them together, and all the non-dy dx terms and put them together. So, oh, we're normal, just not typical. Xy plus y squared. That's all dy dx, so we'll hold on to that for a minute. Plus xy. Plus, again, dy dx xy is going to be separate. We'll move that over in a second. Minus 1, if we bring the 1 over because it doesn't have a dy dx, is equal to dy dx times the quantity. Now everything that got shifted over there is going to be part of this. So here, this is going to be x squared plus xy minus, right? It's going to be a negative. Negative x squared minus xy. The xy would be a minus xy again, dy dx. And a plus 4y cubed. Okay. 2xy plus y squared minus 1 over is equal to dy dx. Okay, we need to take it at 1, 1, which is going to give us a second there. This is going to be 4y to the third minus 2xy minus x squared. I think so. Taken at 1, 1, this is going to get us 2 plus 1 minus 1 over 4 minus 2 minus 1, which is 2 over 4 minus 2 is 2 minus 1 is just 1. All right, so 2. M equals 2, and that's going to get us y minus 1 is equal to 2 times the quantity x minus 1, or y equals 2x minus 2 plus 1 is going to be minus 1. Y equals 2x minus 1. Oh, it just wants what's the slope. Oops. Right, so that's actually the answer. M equals 2. We had A, 2. There you go. B, 1. C, 0, D -1, and E -2. Okay. Awesome. 12. Actual 12. What is the equation of the tangent line to the other curve? Oh, you know what? That's my problem. I mixed questions. Right, this was not what is the equation. What is the slope? This other one down here was what is the tangent line? What is the equation of the tangent line? Really? How'd that happen? To the curve. Y equals x cubed minus 3x squared plus 4x at the curve's inflection point. Ooh. Mean. It's not really, but you know. This is like a two-step process rather than a one-step process. So curve's inflection point is going to be when y double prime is equal to 0. So we want to know when do we get 0 from. Y prime is equal to 3x squared minus 6x plus 4. Y double prime is going to be the derivative of that, so 6x minus 6. All right, so that's just x equals 1. Okay, so then what is the equation of the tangent line to that curve? So now we know that x is equal to 1, and it's a explicit function of x. So right now we don't need to worry about finding the y value of that particular point. Right, so then we take y prime right, y prime is equal to 3 minus 6 plus 4, which is going to be 7 minus 6 is 1, which is going to be our m value for this. These are in all, well, not all, but most of them are in slope-intercept form, so we don't have to convert most of the time. A is y equals 2x minus 3. This is why I hit the brakes earlier, because I was like, wait, y equals 2x minus 3 is the only equation that's remotely close. Oh no. That's when I realized I had done 13 instead of 12. C, y equals x plus 1, D, y equals 3x minus 2, and E, y equals x plus y, nope, x plus y equals 1. This is negative x plus 1. So very similar to that one, but not quite. If m is 1, then already we've only narrowed it down to b and c. So that is already like test taking wise, you've got it narrowed down to two choices. You would not, nor should you, at the beginning of this, just be like, well, it has to be either B or C because those are the only two that have the same slope. Right? That doesn't always work. It could very well be that that's a trap. I have done that before. Or I was like, yeah, sure, you could figure out what the answer is just from one little thing, but then it's like, how clever are you to recognize that you can just figure it out from one thing earlier on? I try not to do that, but occasionally it happens. Okay, so with this, then we say we've got y minus y0 is equal to 1 times x minus 1. And okay, so this is the point at which we actually do need what the y value is for the original function. Okay, so y equals, this would have been 1 minus 3 plus 4. Don't do it here. I mean, sequentially, that's the correct spot for it, but 5 minus 3, right? So y equals 2. Okay, so then this is when we get xy as 1 comma 2. So 2 minus y0 is equal to, oops, wait a minute, no. Y minus 2 is equal to 1 times x minus 1, right? Y equals x minus 1 plus 2. There we go. So y equals x plus 1. C. My spouse skipped that one. I mean, to be perfectly honest, she was probably like, I already know how to do that. That's not an issue. This is Calc 1 stuff. Trivial. Alright, 14. If f of x is equal to 2 times the absolute value of x minus 1, plus parentheses x minus 1 squared what is the value of f prime at 0? Okay, so 2 absolute value x minus 1 has been shifted right 1. And so the negative branch exists at x equals 0. So that means that the slope, right, f prime at 0 is going to be equal to negative 2 plus, and now we take the other one. So here, this is going... Why'd you have to tip over like that, honestly? Yeah, so f prime at 0 is going to be equal to -2 from that particular branch plus this is going to be 2 times x, which is going to be 0 minus 1. Again, here, this is the quadratic function, but it's been shifted right, and we're looking over here at x equals 0. So that's going to be negative 2 times the quantity, x minus 1, times the derivative of the inside, which is just 1. So we don't have to worry so much about that part. This means that this is going to be a -4 total between the two parts. So let's see if we got that right. 14 A, 4 B, 2 C, 0 D, -2 and E, -4. Cool. Yep. I'm doing a lot of these from like a function analysis standpoint, so it's what I did in terms of pre-calc. Let's see, put that down. If f of x is equal to e to the x arc cosine of x over cosine of x. Then the slope of the tangent line to f at its y-intercept is what value? So A, -pi/2, B, -1, C, pi/2 minus 1, D, 1, and E, pi/2 plus 1. All right. Vistolis, good night. Thank you so much for coming in. Anakin, Luke, I know you're probably already gone, but also good night. We will come back to this question right here in just a couple of minutes. We have an ad break that's going to run, so might as well take our 3 minutes, walk downstairs, refill any of your waters, drinks, cycle your water, do what you need to, and we will be back in 3 minutes. Thank you so much, everybody, for coming. Support math here on Twitch, and we'll see you in just a few minutes. Thank you so much, everybody. Thank you for the follow. The name makes me a little nervous, though. Right. So, as per usual, we're going to attempt to remember all we learned today from my Tai Chi class and see if we can't remember. Well, my son owes me some black modeling paint for D&D stuff. Unfortunately, that was how it was left, sideways. So, that one's gone. Oh well. Alright, so for our Tai Chi, we are going to do our quick warm-up here. Quick trunk rotation, and again, if we tuck into the inguinal creases, which are the storage locations of the Chi, which is not in terms of, magical power, not so much. But we do have biomechanical reasons to kind of store energy into muscle fiber. So here we put some of the muscle, we take, bend the muscle fiber in such a way that it's almost like a coiled spring right in here. And then when we push off of that, it allows us to straighten our body in a fairly fast manner. And then we just give it a little bit of a spin here. And if we tuck into the inguinal crease while we're doing all this, it gives us a bit more power, and it looks like we're dancing. Not to be confused with actual dancing, because I'm no good at that. This is mostly to improve the blood flow and synovial fluid movement within the joints, so kind of protects us from injury as we're doing stuff. And the idea is that we're basically more or less going to allow our hands to swing freely and not have to add any energy by, forcing our arms upward. We're going to be just like a kid on a swing. Totally kids on swings, yeah, not us. Give it a little bit of a push. By just coming down a little bit on the downswing. Increases speed, adds energy to the system, allows our arms to swing even higher. And then same here, forward and backward. And we also try not to let the arms just kind of fall, because that jerks them around a lot and that can cause some damage. So try to, as much as we can, soften the fall. Switch. Great. We're also going to stand arms out just a little bit like this. Fingers kind of flex a little bit. Pull up on the neck and the spine just as if you're being suspended like a marionette. And then we kind of tuck into one of the inguinal creases, push over to the other side, turn, come back, turn, come back. This is what is called a bear pose. And so we do this movement like this to kind of connect the arms and the upper torso, trying to make sure that we're all moving together as one unit. Right. And then we do what's called cloud hands, where we come up as we're doing this. So it's still using the fundamentals of the bear pose, but now we're using like a ward off every time that we move through. If anybody missed the series that I did earlier on Nine Souls, it is available on YouTube at Obi-Wan Pez, and the game itself is very much all about Tai Chi and the connections with Tao and Taoism, philosophy, all sorts of stuff like that. So it is rather interesting if you want to take a look at it. All right. So start feet together, bear pose. Tuck right, step left, straighten out. Energy ball, tuck left, turn on the heel. Shift weight. Shift left. And what's this? Ward off left. Keep the right hand lively but down. And from here, we lock in with the right toes, or pivot on the right toes, and then step out as we go to right, ward off. Then we do a roll back with the right as we shift back, press, shift forward, come back and separate, and then push. From here, we go back, rear loaded stance, turn, keep the left foot stuck to the ground, and shift the weight back. The arms come down like this, and then we do single whip, which then uncoils the left leg. We step out left with our left hand, and then we shift weight and turn both the left hand and the right foot at the same time as we shift the weight forward. Everything comes down, step right into lift hands. Bring everything back and strike the shoulder. Then we turn both the left foot and tuck into the right inguinal crease and go to white crane, barely touching the ground with the toes of the left foot. Pretty much all the weight is going there. All right, then we need to advance 2 steps, so we're going to just shift to here. All right, we're going to do brush knee. So we're going to do a double block and then step forward with both a strike and a brush parry. Step up right, bring to left stance, which is called strum the lute. Tuck your hips under. Hey Pen, how we doing? And then we do another brush knee. It's a Pen Center raid. How's it going, everybody? From here, I'm just going to shift a little bit. We lean back. We bring our front leg to 45, and then as we come forward, right hand goes to a fist. And then we're going to step through, turn the right knee, step sideways with a brush, with a parry and load, and then we step through and we pop here. This is going to be a punch going straight out. Then we tuck into the left inguinal crease, bring the hand underneath, take the weight off of the right arm with the left arm, slip it through, and then go to a push. Then we go back, turn left. We're again in the pigeon-toed type stance. Bring both arms out, straighten out the stance, come back up, right arm holding up the left one. Should be slightly on the left side there. Okay. How's everybody doing? Hey Dixie. Siseko, how's it going? Good evening, whatever it is. Hope y'all are having a great evening. We're just taking our Tai Chi break and then continuing with the GRE type stuff. Let's see, from here, I'm going to turn this so that you can all see it. We come out like this, turn on the left. Nope, that's the right. Turn on the right toes, bring the hand up, bring this hand down toward the knee, and then we're going to step way back to the right, and then bring all of the weight this way, and at the last second we turn the left foot from being facing this way to being facing 45, well, more or less 90 degrees inside the room, and that allows us to do a little bit of a strike this way. It's called carry tiger to mountain, because essentially what you've got is somebody who's being super aggressive and trying to hit you and stuff like that, and you just kind of like take them from here and you bring them over here. Tends to use their energy against them. So we throw that way, and then we go to a roll back, press, and push like we always do. Shift the weight back, come back around this way, tuck into inguinal crease here, and do another single whip this way. Yep. Step out, lean forward. So we're going to do another block here, step back, and now when we bring the leg down here, oi, I don't have room for this. When we bring the leg down over here, we then do a swipe hit this way, stepping forward, and then step forward again. But this time, this is going to just kind of pop at the person here. And then we do what is called repulsing monkey. I know, right? So this is going to come back around to the right. From here, this is going, nope, that's this way. This is going to come to here, and then this is going to come back to about here, sort of at the same time, like that. This basically keeps somebody at a distance, so they're not going to try and attack you terribly hard. And if they do, you just go, okay, and go the other way. My instructor says it's actually kind of like how monkeys do literally move, that they pretty much always have the same foot and hand forward at the same time. So it's always going to be this kind of like similar retreating style as we start moving back. And that's what we learned today. Unfortunately, I did not learn quite as much as I thought I would because I was still a little bit behind on some other stuff. So it happens. Hello and welcome anybody who doesn't know me. My name's Obi-Wan Pez. This is N Simplex Pachinko. We do mathy stuff on Mondays and Wednesdays and gamey type stuff on Tuesdays, asterisk Thursdays and Fridays. Oftentimes it's just how I'm feeling. I know we skipped a couple of days here and there in the last couple of weeks just because we got all sorts of crazy stuff going on. We were planning on moving on Monday and Tuesday of next week, so like there's just not going to be any stream in there-ish. Thursdays, lately I've been doing a TTRPG prep for Titan's Grave, The Ashes of Volcano, which is co-written by Will Wheaton and his son Ryan, as well as Jackson Lansing, somebody else who did another awesome TTRPG called Vast, which I desperately want to run, but literally the rules are not available. So I could go back and watch literally every episode of it as it's on like a hidden server somewhere. Yep. But I will not, unfortunately, be able to actually do much with it. That's weird. I thought... Oh, yes, there we go. Anyway. Yeah, Dexy Mathman was a formative part of my growing up. And my parents, it was like Square One TV was like the one show I was kind of allowed when I was super young. Because they were like, absolutely, you can watch a math show. They had me... It was basically like the only things I could watch were Sesame Street, Mr. Rogers, and Square One TV. And then like there were a couple little things here and there. The Price is Right was one that they were like, actually, it's semi-educational. Price is Right is teaching you about economics. Ish. Sort of how it all works. Okay. So the slope of the tangent line at F at the y-intercept of this thing. Didn't appreciate MathNet. Yeah. MathNet was definitely for my father. Because, like, we'd watch something and he would just burst out laughing because, let's see, the one that he really loved was the towing one. They stole. There was a wrecker that was running around L.A. stealing cars and then sending it to a crusher, and the like teenage girl companion of the week was named Liso, which slightly but George at one point, like they're having kind of a back and forth between George and Kate and Liso about something, oh, well, why don't you do this? Oh, why don't you do that? And they're like, yeah, we can't do that because, we're the police. We're not like, our database has some information, but not all of the information. And she asks if, I don't remember what the question was, but she asks a question and George says, it ain't necessarily so. And my dad's like, what? And then it hit him all of a sudden that, like, George put on this accent of, it ain't necessary, because her name is Liso, and so therefore it ain't necessarily so. And, like, he lost it. He was just laughing for minutes. And it was a little ridiculous, but I liked it for all sorts of reasons. And when I got older and could actually do the oh yeah, yep, string bean. My big one that I really liked also was the Fibonacci sequence with the parrot. Who definitely was not just the guy with the husky voice through a voice modulator. Definitely was not him. Alright, so we want to find the slope of the tangent line again. So this is going to be f prime at x, which we need to take. This is e to the x, our cosine of x over cosine of x, plus e to the x derivative of our cosine, which, if you can never remember what it is, just derive it real fast. So our cosine of x equals y, therefore the cosine of y equals x. If we take the derivative of this, then we end up with the negative sine of y dy equals dx. And this is dy dx is equal to 1 over, this is negative 1 over sine of y. And then, if we want to say, okay, well, what is the sine of y, the cosine of y was x over 1. Hey, famous. Yeah, Penn was live. You missed it. So then this one over here is going to be the square root of 1 minus x squared. So then the sine of y is going to be, we have negative 1 over. The sine of y is now the square root of 1 minus x squared over 1. So I'm not going to bother with that, but, you know. So dy dx is going to be this thing right here. If you don't remember how to do it, just derive it. Use the other form of it, which is the easier one, right? Use the cosine thing. Okay, plus. So this is going to be e to the x times a negative 1 over square root 1 minus x squared over cosine of x. Okay, plus. Now we got to take the derivative of the bottom, leaving the top as it is. So e to the x r cosine of x. Okay, this is, right, because it is this is fine. Ugh. dy dx over there. Arrowhead. All right, fine. Okay, arrowhead. And then the dx, nope, the dx from over here needs to go back over there. Okay. This was cosine of x raised to the negative first power that we're taking the derivative of. So it's going to be negative 1 cosine of x raised to the negative second power, then multiplied by the derivative of the cosine, which is a negative sine of x. So cosine squared of x is going to be down here times a sine of x, with both the negative from the power and the negative from the derivative of the cosine multiplying each other out. So that's going to remain a positive value. Okay. Awesome. That's so disgusting. All right. At the y-intercept, right, means that here means that we're going to take f at 0, and we're going to get e to the 0 times arc cosine at 0 over cosine of 0. So cosine of 0 is 1. That's at least nice and easy. E to the 0 is 1. Arc cosine of 0. So what angle of theta is going to get us a 0 for the cosine? So that is going to be pi over 2. So the y-intercept is going to be 0 comma pi over 2. Which then means we're going to go over here and we're going to say, all right, this is going to have right? F prime at 0 is going to be equal to, again, e to the zeros are all gone. Cosine of zeros are all 1s, so they're all gone. Then we get the arc cosine of 0, which again is pi over 2. We already know that from earlier. Minus 1 over square root of 1 minus 0. So that's all just 1. And then here we have the plus all of this stuff, and it doesn't matter what this is because this is the sine of 0, which is 0. So all of this right here is 0. All of this here is just 1. And this part here is pi over 2. So f prime at 0 is going to be pi over 2 minus 1. That is the slope at that particular value. The slope of the tangent line is going to be pi over 2 minus 1, which is matched by C. Awesome. Woohoo! $15? Yep. Cool. $16. Let y equal 1 over the square root of x cubed plus 1. Oh, yeah. I already have some. I just go black. Don't. So yeah, I've just been drinking black coffee for a few years now, mostly because I just prefer the taste of the actual coffee itself, but also, like, this is one of those things that I gripe about all the time. If you do not enjoy your coffee black and at every temperature, okay, I understand if, like, acidity regulation or if you just don't like black coffee, fine. I did see somebody posted a while, I don't remember, it must have been a video. They were like, no, what you want is a coffee milkshake. You don't actually want coffee, you want a coffee milkshake. And like, if you want a coffee milkshake or, whatever, like, you don't really need super great coffee to do that. Like, just go get whatever crappy coffee you're going to have. It's fine. But do not buy something that is like $20 per pound if you are going to just dump milk and sugar in it. Unless there is a legitimate health reason that it is better for your body. But this stuff is from a single origin, fair trade, all this other stuff, and like, it's really good stuff, but you really have to appreciate like the coffee itself. And if you don't, then like, why are you buying this? Like, $5 for how much? Like, a coffee? Sure. That's usually what we get around town. It's £3.70, which is, about $5. Oh, the guy at the place I got one this morning tried to kill me though. He filled this like to about here, and this is like all the way to the top is pretty close to a liter. So he filled it up to about here. It was 6 shots of espresso plus whatever water to get it to this point. And I think I could smell color. I was like, huh, that's probably not good. hmm Um, oh, I'm going to hashtag not sponsored. Um, oops. Oh no, the website went away. No. Oh, please tell me they didn't go out of business. So it's these guys from Comayagua, Honduras, and oh no. Oh, okay. Yep, that's not surprising. We recently had to disable website orders due to a significant increase in tariffs from importers. Shocking. Jerks. So this was May 2025. Yep. So they've been not doing they've been not doing their website for a year almost. Man. But I will post these guys. This is their Facebook link, which I understand. But anybody who you know might be interested in finding them, I believe that they were they were um, shipping to Baltimore directly, and then from Baltimore they were able to get it all across the U.S. Again, with the tariffs issue that's been going on for a while now, who knows what they're going to be doing? It's quite possible that they're not going to be doing anything. It's very sad if that's true. I met those guys. They were super awesome. And like their coffee was just absolutely amazing. They had multiple different lines that worked really well. They had a wash process, which is basically like your generic coffee. Everybody does it. They pull it off the branches. They, you know, take the coffee berries off and then go compost them, and then they like rinse off all of the berry gunk that gets on them, and then they roast that and then send it on. There was also a natural process where they leave all the coffee berry gunk on there, and then they roast the beans with that like slightly aged berry stuff on it, and then they just kind of like brush it off at the end without, they let it sink in and mature, ferment with it a little bit, and then they roast it. And that was unbelievable. The first time I had it, I pressed the window, the little plastic window that you could see all the beans through, and like it left behind a little bit of oil residue on the plastic. I was like, ooh, that's gonna be good. And then they also do one that is a honey process where they take off, like take the take the beans out of the coffee berries and then like ferment them in honey. And I don't remember if they rinse off the berry gunk or if they like let it sit in the honey, but either way, I loved all of their stuff. It was just brilliant. And I really hope they come back again. And I've lost my taste for dark roast coffee because it tastes burnt to me on almost every single brand. And I like the different notes that are in the lighter stuff. That's also, the lighter one actually has more caffeine in it. So okay. If X increases from 2 to 2.09. Yeah, since it has less caffeine. Yeah. Right. Which most closely represents the change in Y. So A is 0.08, B is 0.04, C is negative 0.02, D is negative 0.06, and E is negative 0.09. You found it out not too long ago, which is wild. Yeah. I mean, it makes sense, right? If you are going to heat something, then typically it's going to break down more of the compounds that are in it. So caffeine's no exception. It does take a bit of doing, and if you got rid of all of the caffeine in the coffee by roasting only, it would ruin the beans themselves. They would become absolutely inedible, I guess is the best way to put it. Okay, so if I just take the derivative of all of this stuff as a generic derivative, this is going to be the change in y, or dy, is equal to 1 over, this is 1/2 exponent on x cubed plus 1. Negative 1/2 exponent. So if we take the derivative of this thing, this is going to be negative 1/2 parentheses x cubed plus 1 raised to the negative 3/2 times, and now we get the derivative of the inside, which is going to be 3x squared. It's actually not too bad. And then we have to take the derivative of x, so that's also going to be dx. Okay, so negative 1 over 2 parentheses x cubed plus 1 raised to the 3/2 power in the denominator. And then up top, we get a 3x squared times dx. Okay. So then, we could also do this as delta y is equal to a negative 3x squared over 2 parentheses x cubed plus 1 raised to the 3/2 power times, oops, not d, delta x. Federico, how's it going? We are differentiating up in here. The x increase right? We don't know what the y increase is, so we're going to put delta y over there. We do know that the current x value is 2. And we would like to increase it to 2.09. So the change in x is going to be a 0.09. Down bottom, we get the 2. We get 2 cubed plus 1 raised to the 3/2 power. Oi. Now, I don't know about anybody else, but I did this in Calc 1. I don't know if I actually taught it in Calc 2 explicitly. I thought it was a Calc 1 thing. Okay, this is going to be a -3 times 4 all over 2 times. This is 8 plus 1 is 9. 9 square rooted is 3. Cubed is 27. 0.09. Right, at this point I'd use a calculator and do it, but yeah. Here we get 1, this is going to be 9, this is 1, this is going to be 2. So delta y is equal to 2/9, -2/9, times 0.09. This 9 divides out that 9, we get a 1, and then we multiply it with a 2, -2, so -0.02. C. Woohoo! Yep. Awesome. Yep, cool. Alright, back up to the top. That is number 16, so 17. If f of 1 is 1, f prime at 1 is 1, then the value of the following ridiculously large thing, ddx of f of x cubed over x times f at x squared at, well, where x is equal to 1 is which of the following? A, 1. B, 0. C, -1. Good. D, -2. E, -3. I like the consistency. Even if some of these answers are just like not even remotely possible as distractors, like like I said, I can appreciate the consistency if they're always like separated by the same amount. Okay. So the derivative of this thing is going to be implicit. Yeah, essentially. So what, I mean, all we really need to do is say that we're going to take the derivative of the top, which is going to be f prime at x cubed times 3x squared, the derivative of the inside, chain rule, right? Divided by what's already there, so x times f at x squared, plus the top, which is f of x cubed, divided by, we need to take the derivative of that whole thing. So the derivative of, we can also do this individually, like separately. So we just do the derivative of the second part, which is x to the negative first. So you take the derivative, it's going to be -1 over x squared. And then f of x squared like that. And just leave that for now. and then plus f of x cubed over x times, and now we take the derivative of this thing, which is f of x squared, all raised to the negative first power. So this is just the same sort of thing as the 1 over x bit. It's going to be negative 1 over this thing squared then multiplied by the derivative of the inside, which is f prime at x squared, times the derivative of the inside, which is 2x. Yeah, logarithmic differentiation is nice and all that, but the problem here really is also that you've got a bunch of f's, which, like, you can't really take the derivative of, like, the log doesn't help the f by itself. Sure, it separates the multiplication and division. Sure, that works. It's fine. You could do that. I just don't care. For me, this is pretty much easy enough. Like, it'll work. So what we want now is f at 1, which is 1, f prime at 1, which is 1. So, like, literally all of the pieces here are just going to be a bunch of 1s that have some coefficients. Right? So we've got, again, x cubed is 1. So this is f prime at 1, which is 1. 3, x squared, x is 1. X is 1. F of x squared is 1, so f of 1 is also 1. So the first term is 3. Minus. F at x cubed is 1, f at 1 is 1. X squared is 1, x squared is 1, f of 1 is 1. So this one's just minus 1. Okay, minus f at x cubed is 1, f at 1 is 1, times f prime at x squared is 1, f prime at 1 is 1, times 2 times 1. Divided by x is 1, x squared is 1, f of 1 is 1, squared is also 1. That's why I like this one. It just, like, all this stuff just disappears. It's fine. So 3 minus 1 minus, this is going to be 2 over 1, so 2. So that's all just equal to 0. I know some of my students feel kind of robbed, and they're like, oh man, it's 0. All this time and effort, and we got a 0. And it's like, no, that's actually a significant answer. Don't dismiss it. All right, ads are about to start. I'll see you all in just about 3 minutes, so thank you so much for coming. Cycle that water, take a walk, do whatever you need to, and we shall return very shortly. Thanks so much for coming, everybody. Federico, you mean the if we were to do it with logarithmic differentiation? Right. Das thou in hoist? These are fairly simple 20-pound weights, approximately 9 point something kilos. We just typically do some arm work, which helps out a lot with like doing martial arts and stuff like that, just to make sure that we don't languish and completely let our muscles atrophy. Typically want to go slow up and slow down. Helps build muscles on both directions. And if we just let it fall per gravity, then that's really bad for our body and stuff like that too. My spouse and I did a program called Shailene Extreme. Like, oh God, almost 20 years ago. The idea was that you would basically lift whatever weight it was at like the high end of your ability, that you could do at least like 10 of them without hurting yourself. And it would push you to extreme failure within like that time. That you would be like, okay, I can only do about 10 of these before my muscles are completely failing. And failing as in like, I literally can't lift anything anymore. And then you'd hold pretty much at that weight for 2 or 3 sessions and then reassess. Try to go higher and keep doing that over and over and over again. And she had like a number of kind of different videos that would use a slightly different workout set that would take ever so slightly different exercises. And so it would help you build up, different muscles and all that stuff. And it helps to build up the lean muscle, which doesn't get you all bulky and stuff like that. It's just it builds up much stronger muscle that doesn't show very much. So it's kind of like a favorite group of exercises. Okay. Anyway. So the only issue with doing logarithmic differentiation with this is you'd have to come at it from like, y is equal to all that stuff. So f of x cubed over x f of x squared. Do logarithm first. This is going to be the log of f of x cubed. Minus log of x minus log of f of x squared. And then take the derivative. So this is going to get you y prime on y is equal to 1 over f of x cubed times the derivative of the inside is f prime of x cubed times 3x squared minus 1 over x minus 1 over f of x squared times f prime of x squared times 2x. So y prime is equal to the original f of x cubed over x f of x squared times all that again. 3x squared f prime of x cubed over f of x cubed minus 1 over x minus 2x f prime at x squared over f at x squared. And then if we evaluate this at x equals 1, f at x equals 1, f at 1 equals 1, and f prime at 1 equals 1, then we end up with, right, this ought to come up with the same thing. Again, all of our x squareds, x cubes, and x's are all 1s, and that leaves just f of all those things. So we get a 1 out front. Doesn't change anything there. It's fine. This is a 3 minus a 1 minus a 2, which again comes out to be 0. So I'd say this one requires a little bit more thinking and making sure that everything is working right. But either way, right, all of it works. This one requires a little bit more quick thinking in terms of the overall either power or quotient rule. Whereas over with logarithmic, you've got more to think about in terms of just making sure your chain rules are correct, and then making sure that you've got your y prime isolated. Because that's another thing, right? Is that you can't just be like, okay, I'm just going to take the log of the fraction and then take its derivative and then I'm done, right? You have to multiply it by the original thing because it's y prime over y. So it's easy enough as long as you remember what you're doing. That was B. 18. If n is a positive integer, what is the value of the nth derivative of f of x is equal to 1 over 1 minus 2x at x equals negative 1/2. Righto. So we have the 0th derivative here. Oops. That one. We have the 0th derivative here, which is the original function. We have the first derivative, which is going to be f prime at x is equal to. This is going to be this stuff all raised to the negative first power. We take its derivative. We're going to get 1 over 1 minus 2x raised to the negative second power, which then drops underneath, right? We need a negative from the negative 1 coming down. Then we also need the derivative of the inside, which is going to be negative 2. This is going to be 2 divided by parentheses 1 minus 2x squared. Okay. Second derivative, f double prime at x is going to be, we have the 2 that's sitting up front, or up top. We have the negative 2 that is coming down from the exponent. And then this is going to be 1 minus 2x to the negative third power, so drop underneath again. And then here, this is going to be the derivative of the inside is again negative 2. So those are going to be multiplied together, which means we get this as positive 8 divided by parentheses 1 minus 2x to the third power. The third derivative is going to be equal to, we have the 8, which was already there. We have the negative 3, which is going to come down from the exponent. We're going to be left with 1 minus 2x to the negative fourth power, so that drops underneath again. And then the derivative of the inside is again going to be a negative 2. So then this is going to be a, let's reparse this. So this one is going to be a 1 factorial, because here we're going to multiply by every exponent that's coming down. Then we're also going to multiply by the number of 2's, the same number of 2's as is the derivative. So this is going to be 2 factorial times 2 to the second. This number here is going to be 3 factorial times 2 to the third power. So 8 times 6, right, is 48. 1 minus 2x to the fourth power. So as we get this going on, the nth derivative should be nth derivative of f being, okay, it should be n factorial multiplied by 2 to the n over 1 minus 2x raised to the n plus 1. Should be what we get. Right? Every time that we advance, we're getting 2 negative numbers, one from the exponent and one from the derivative of the denominator. So this is what I'm seeing, pretty sure. Right? And then we want to know what's going to happen at x equals negative 1/2. So f nth derivative at negative 1/2 is going to be equal to n factorial times 2 to the n divided by 1 minus 2 times negative 1/2 bracket to the n plus 1. Should be then, what is that, 2? 2 to the n plus 1? Ooh, that's nice. So if I'm right, this is going to be a positive 1. So 1 plus 1. It's just going to be 2 to the n plus 1, independent of what n is. Those are going to be one off from each other. So that and that are going to go away, and we should just get n factorial over 2. Let's see. A is 1/2 n to the n. B is 1/2 n factorial. C is, and that's what we got right there, B. C is 1/2 n. D is n. And E is n to the n over n factorial. Awesome. Hey, look, it's something we actually got. Right. Right. Let f of x be continuous on a bounded interval. A to b, where a is not equal to b, one should hope, such that f at a equals 1, f at b equals 3, and f prime at x exists for every x inside of open AB. What does the mean value theorem say about this f? All right, without looking, right? The mean value theorem is going to say that all f of c, okay, hang on, let's go back. For all c inside of a to b, there exists f at c such that f at a, wait, hang on. No. It's not for every. It's the other way around. Yeah, okay. So for every for every y value inside of 1 to 3, there exists some x value, which we call c, which belongs to, oh, shoot, no, that's right, okay, which belongs to a to b, such that f at a is going to be less than or equal to f at c is less than or equal to f at b, or 1 less than or equal to f at c less than or equal to 3. So every single y value will have a corresponding x value along that interval a to b. At least one, right? That should be the statement, right? Or in layman's, right? Every y value on 1 to 3 has a corresponding x value on a to b. All right, what does it say? There exists a number c on the interval a to b such that f prime, got it wrong. Nope. No, I got it wrong. Mean value theorem of calculus. This is the intermediate value theorem of like pre-calc. Yeah, I'm too tied to my pre-calculus. Okay, now that I've looked at that, I remember what the mean value theorem is. Right, mean value theorem says that if we've got a function that's here to here, right, this is our 3, this is our 1 between a and b, then the slope value that goes between a and b right, there exists some x, which we, again, x called c along the interval a to b open, such that f prime at c is going to be equal to the mean value, the average slope between those two things. So f at b over, minus f at a over 3 minus 1. No. B minus a. Right. Which we know this is 3 minus 1 over b minus a, which is 2 over b minus a. Okay, so whatever that might be. There is this number c in the interval a to b such that f prime of c is equal to 0. Doesn't have to be the case, because f prime could be just a linear function, or f could be a linear function going from a to b. a comma 1 to b comma 3, right? Could just be a linear function, so it'll never have a slope of 0 in that case. There exists a number such that f of c is equal to 0. No, right? Because this is not guaranteed to go through 0 at any point. In fact, right, it's going from 1 to 3. So it's not guaranteed. Again, it could be a linear function. Just use that as the example. There exists a number in the interval a to b such that f prime of c is equal to 2. So this is close, but the problem is that b to a doesn't necessarily have to be a 1, right? It could be stretched over a really long horizontal horizontal interval, right? It could be like 1,000. In which case, that's not guaranteed. Right? It could be 2 over 1,000. There exists a number c in the interval a to b such that f prime at c is equal to 2 times b minus a. Really close, but not quite. Last one says such that parentheses b minus a times f prime at c is equal to 2. That's the one we want, because what they did is they just got rid of the fraction. Right, so they said, okay, let's take this thing right here and let's move the b minus a by multiplication to the other side, make it f prime at c times b minus a is equal to 2. So that is E. Now, who would say that? Well, I mean, most people wouldn't, right? They would say f prime at c is equal to 2 over b minus a. But we don't have that luxury here. They just decided, let's not include fractions. So, that's their prerogative. All right, 20. What is the maximum area of a rectangle inscribed into a semicircle of radius A? Okay, this is always a fun one. So what we're doing here is we're doing optimization problem. Okay, close enough. Ew. All right. So radius is A. We want a square. No, we want a rectangle, which is going to be inscribed. Ugh. Into the semicircle. Okay, so first of all, we have to assume that this is going to be symmetric, right? Because rectangles are symmetric about the midpoints. So if we were to, again, draw something like this, say, okay. Rectangles are going to be horizontally symmetric. They're also vertically symmetric, but we're not going to worry as much about that. Point being, right, this point here and this point here on the top corners are going to be equidistant from the midline there. And so we only really have to focus on one of them. We could, for instance, let this point here be 0, 0, just for simplicity's sake. Okay. So the area under the curve is going to be, right? This here is going to be a distance of A. At the point x comma y, whatever that might be. Since it is a semicircle, we know that the equation that's going to be drawn by that particular circle as a whole is going to be x squared plus y squared equals a squared. If we want to simplify, quote unquote simplify, we could also do that. You know what, we'll come back to it. So here, the area is going to be equal to x times y. Yeah, we're going to need that. Fine. Right. So this is also the thing, right? This is the area of half. Thanks, famished. We'll come back to that in a bit. So we could also say that this is going to be, right, just put the half the area and then not worry about the exact thing that we're looking at. Don't worry about the total area until the very end. Because it's not going to matter, right? It's going to be off by a constant. Oh well. Derivatives don't affect constants. Right? It's just going to be kicking around. This does mean that the y value could be x here, x times the y value is instead, right, y equals square root of a squared minus x squared. This is half of the area, which if we take the derivative of that to say, where's the change in the area going to be where's the change in the area going to be 0? So here, when we maximize the area, we want the d area dx to be equal to 0. And, you know, in theory, this could be d area dy as well. It doesn't really matter. I am saying area specifically because the radius of the circle is little a, so we don't want like d a dx. We want d area or d big A dx to be 0. So here, if we take the derivative and the derivative, Horrible notation for doing that, but you know what? It's fine. Then we end up with our 1/2 area prime equaling 0 equaling, take the derivative with respect to x of this product. So now it becomes the square root of a squared minus x squared plus x times the derivative of this radical is going to be 1/2 from the exponent times a squared minus x squared raised to the negative 1/2 multiplied by the derivative of the inside with respect to x is going to be a negative 2x. Okay, now goodness. If we multiply both sides by the square root of a squared minus x squared, we're also going to do that over here as well. But that's 0. So it's not going to change any. 0 equals. Here, the square root times the square root leaves the a squared minus x squared out by itself. And in the second term, the a squared minus x squared raised to the negative 1/2 is the square root, but on the bottom. So we divide out the square root that we just multiplied by. And that gets us a plus 1/2 x times negative 2x. So this this 2 and 1/2 will divide each other out, leaving a total negative 1 x squared. So the 0 is equal to a squared minus 2 x squared between both of them. This is a negative x squared. This is a negative x squared. So negative 2x squared. Those come to the other side. So now we get a 2x squared is equal to a squared. And we want to solve for x in terms of a. Yes. Solve for x in terms of a. So x squared is equal to a squared on 2. Square root of both sides, x is equal to square root of a squared is a over square root of 2. What is the maximum area inscribed? So we want x times y. That's x. Now we need y. Yup. Okay. X squared, interestingly enough, right? We know that y is equal to square root a squared minus x squared. X squared is equal to a squared on 2. So that means y is equal to square root of also a squared on 2, which is equal to a on root 2. So x and y have to be equal. And then here this is multiplied by 2 because we've got them on either side. So it's just x squared, which is a squared on 2. Right, xy. 2xy is equal to the area, capital A, which is going to be 2 times a squared on 2, which is just a squared. case. All right, so A was root 2 over 2 a squared, which is also a squared on root 2. B was root 3 on 2 a squared. C was a squared, which was the answer that we got. D was pi over 2, pi over 2 root 2, a squared. And E was a squared times root 2. Right, so we got A, which was like, if you weren't paying attention, you might accidentally just get a squared and be like, haha, that's the answer. Not quite, in fact, because that's x. Okay, whatever. Maybe you figured that y was just going to be a, I guess, or something, or you multiplied it by a, the radius of the circle, instead of... I don't know what people would think if that was the case, but a, whatever. It works. A squared was what we got here. Okay. I think that is probably a good stopping point for the night. Did the first 20 questions, and we will head out and find if there is somebody doing any sort of mathy stuff tonight. Dr. Gold might be another half hour. Don't think, it looks like there isn't anybody currently on doing mathy stuff. Okay, so we got Casey Snow Art, who is currently doing some, looks like lava pony. Racodactylus, doing what makes fake science fake. Reminder that Racodactylus does psychom and specifically conspiracy theory studies. It's like, what's going on with all that? Yeah, you know what? We'll go see Reiko. Okay. Hope y'all are having a good evening. We will be coming back tomorrow, probably, for some Titan's Grave TTRPG planning. I have some ideas. We have a new person coming in this weekend, and so I've given them like kind of an idea of what needs to happen, and hopefully he will dance. He will dance like a puppet. But I'm giving everybody some leeway when we start getting into stuff. It's just a matter of like, where his character is coming in. It's kind of he's gonna have to take a few pieces of direction and then just go. So we'll see how that goes. Hope you all have a good night. We'll be back, like I said, tomorrow probably for TTRPG prep, and then Friday for some sort of game. What am I doing? What did I do last week? I don't remember. Anyway.